Today we're looking at the dot product, a way of multiplying two vectors to get a single number. So say we have two vectors here, we have A and B, and they have some angle in between them, theta. The dot product, which is represented by a sort of raised dot, is A dot B equals the magnitude of vector A times the magnitude of vector B times the angle in between them. Now it's important to know that this angle is actually the non-reflex angle, so it can't be the reflex angle. Reflex angle meaning the angle bigger than 180 degrees. So like for example here, this is the non-reflex angle. This would be the reflex angle because it'd be bigger than 180 degrees. Now there's a second formula that doesn't use the angle in between and actually uses the components of the vector. So say we have a vector, our vector A, in column vector notation, it's x1, y1. So again, this means how far along in the x-axis, how far does it go up or down on the y-axis, right? And our vector b is the same. So it's like some x component, some y component. The dot product between these two vectors is equal to the I components multiplied together and the j components multiplied together. Right, and so these two formulas give you the exact same thing. Now, with the formula that does use the angle in between them, there's a pretty common result that you will use in so many questions, and it's got to do with the angle in between them. So this cos of theta is 0 when the angle between them is 90 degrees. So any vector that is perpendicular will have a dot product of 0. Now here's a very important example question because it doesn't even mention dot product in the question. You sort of have to figure out when and how to use the dot product for questions like this. The question is, find lambda for which the vectors u equals lambda squared I minus 2j and v equals I plus lambda plus 4j are perpendicular. Now, instantly you should have in your brains that whenever there's a perpendicular, that automatically means that the dot product is 0. So we instantly know that u dot v equals 0. Now what is u dot v? Well, we have the components, so we can just multiply the components with each other, add them together, just like our second formula said. So we know that u, if I write it in column vector form, u is lambda squared minus 2j, lambda squared I minus 2, dot product with v, which is 1 and lambda plus 4. And we know this should equal 0. So now we just multiply the top row and the bottom row and add them together. So we have lambda squared, because lambda squared times 1 is just lambda squared. And then minus 2 times lambda plus 4. So we got minus 2 lots of lambda plus 4. And this equals 0. Now if we just expand everything out, we get lambda minus 2 lambda minus 8 equals 0. Now, once you look at this, it should immediately pop in your mind that this is a quadratic. Like imagine the lambda was x, it'd just be a simple quadratic, and we have to find lambda for when it equals 0. So let's factorize and solve it. Just so we have lambda minus 4, lambda plus 2, this equals 0. And that means lambda has to equal 4 or minus 2. Another very common question would be to find the angle in between two vectors. For example, the vector A, 2 and 2 root 3, B, 6 and 0. What formula do I know that has a theta in it? And that would be this dot product formula, which is the dot product between A and B equals the magnitude of A, the magnitude of B, times cos theta. Now we have to find this cos theta, which means we need everything else. We can easily find the magnitude because we have the vectors, but what is the dot product? Well, that's when we can use the second formula where we multiply the components together to get the dot product. So for this type of question, you want to find the magnitude, find B using the magnitude formula, and then find the dot product using the second formula that I introduced, which is to multiply the components together. So first off, magnitude of A, that is the square root of the components squared, summed together. So 2 squared plus 2 root 3 squared. Now this is 4 plus 12, which is the square root of 16, which is 4. Let's move on to magnitude of b. So the magnitude of b, you can sort of just see it from here. When one of the components is 0, you don't need any special formula. The magnitude is just going to be the other number. This number means go right 6 boxes, so we already know the magnitude is 6. Right, so now that we have that, we have to find the dot product. We need to find the dot product using the other formula. So this is, we'll just times the components together. So we times the x components together, or the I components together. So 2 times 6, which is 12. And then we add the j components multiplied together, which is 2 root 3 times 0, which is 0. So this answer would just be 12. Now we sub in everything we know into our original formula, which is here. So if a dot b equals the magnitude of a times the magnitude of b times cos theta, then that means 12, which we found before, equals 4 times 6 times cos of theta. And if we rearrange to make cos theta the subject, we get, okay, 4 times 6 is 24, so this will be 12 divided by 24. Simplify this down, you get a half. So we have cos theta equals a half. Now, that means theta has to be pi on 3. And that's the answer to that question. The angle between the two vectors is pi on 3, or in other words, 60 degrees, if you're talking degrees instead of radians. These are just a couple ways you can use dot products and how you'll be tested on dot products. Thank you for watching the video, and hopefully you're a vector pro now.